So now the topic is in single phase induction motors. The topic is reluctance motor. Reluctance motor. What is the reluctance motor means? The reluctance motor is nothing but a single phase synchronous reluctance motor is basically the same as the single phase type induction motor. But why we call the synchronous reluctance motor? This is a very important. The reluctance motors are advanced one compared to normal induction motors. So why we call as synchronous means these motors are rotated at synchronous speed. This is a very important point. These motors are rotated at synchronous speed. So these are the advanced technology compared to previous one. The stator of the motor has the main and auxiliary winding just like as previous. The stator of the motor has the main and auxiliary winding. The stator of the single phase reluctance and induction motor is the same. Stator is the same. The rotor of reluctance motor is a squirrel cage with some rotor teeth removed in certain places. This is a very important one. While comparing the normal induction motors and the reluctance motors, the rotors are squirrel cage type, but some rotor teeth removed in certain places. Where we need, that will be removed. So the teeth is removed to provide desired number of salient rotor poles. Synchronous, there are two types: synchronous reluctance motor, switched reluctance motors. So how much torque produced by using the reluctance motor is K into V by F whole square sin 2 del REL, where T is a average value of reluctance torque, V is a applied voltage, F is a line frequency, delta is a torque angle, K is a motor constant. The torque developed in reluctance motors are very more compared to normal induction motors. So this is a diagram construction feature of 4-pole reluctance motor. This is normally in salient pole structure, salient pole synchronous motor structure. Please see. So what is the principal operation of reluctance motor means? It is a single phase synchronous motor which does not require DC excitation the rotor. So normally synchronous motor means we giving the two supplies, one is in stator, another one is rotor. The rotor must be excited with DC excitation, but in case of synchronous reluctance motor there is no need of DC excitation. This is a very advantage one in reluctance motors. Its operation is based upon the following principle. Whenever a piece of ferromagnetic material is located in a magnetic field, a force is exerted on the material tending to align the materials so that reluctance of the magnetic path that passes through the material is minimum. Please see the reluctance motor. Advantages. The advantage of reluctance motors include the following. It does not require DC supply, stable characteristics, maintenance is less heat, no magnets, speed control. Disadvantages are the disadvantages of reluctance motor include the following. Efficiency is less, power factor is poor, frequency control. The capacity of this motor is less to drive the loads, less inertia rotor is required. Applications. The applications of the reluctance motor include the following: signaling devices, control devices, automatic regulators, recording devices, clocks, teleprinters, gramophones, analog electronic meters, electric vehicles, power tools like drill lathes, bandsaw and presses. So next topic is a stepper motor. Stepper motor. So normally stepper motor also a advanced motor. So in your watches we using the stepper motors that produces the torque, pulsating torque, not unidirectional torque, not continuous torque, that is a pulsating torque. So a stepper motor is an electric motor whose main feature is that its shaft rotates by performing steps. The shaft is rotates in performing step, not that will not rotates continuously, that rotates stepwise, that will choose some angle, that angle on and off, that will gives the pulsating torques, that is by a fixed amount of degrees. The basic working principle of stepper motor is the following. By energizing one or more of the stator phases, a magnetic field is generated by the current flowing in the coil and the rotor aligns with this field. By supplying different phases in sequence, the rotor can be rotated by a specific amount to reach the desired final position. So these are the stepper motors. The shaft rotates. Please observe the shaft arrow mark, that will rotates with an angle that will rotates with an angle, and then again that will rotate at an angle, and then that moves. Please see. So whenever the supply, they have three phases. Please see, A plus, B plus, A plus, A minus, B plus, B minus, C plus, C minus, the winding structure. So this is a stepper motor. So what are the applications of stepper motors are? 3D printing equipment, textile machines, printing presses, gaming machines, medical imaging machinery, small robotics, CNC milling machine, welding equipments. Its maximum torque value ranges up to 15 Newton meter. These are very important. Its maximum torque value ranges up to 15 Nm Newton meters, and the step angle ranges from 1.8 to 90 degrees. 1.8 is a minimum, 90 is a maximum.